The revision slides right here for linear graphing. Okay, don't be too stressed. You will be fine. Okay, let's just get to it. So the first chapter that we learned in chapter 9 here was the Cartesian plane. So just make sure that you have this all memorized. Okay, so when you draw Cartesian plane, okay, there's two lines that you draw. Um, you have the horizontal and you have the vertical line, and they intersect each other at some point. So it's pretty much, if you have a look at my diagram, it's just these lines that I'm highlighting right here. Okay. So you have two different axes, the X and the Y. Just remember, X is horizontal, Y is vertical. Okay. Now, um, if you do draw your graphs from scratch, yeah, you just got to make sure you space them out evenly so that when you're numbering it, it's all the same, okay? But don't stress too much. I don't think you'll be drawing the graphs a lot um, ahead. But yeah, just know that. Now, origin is basically the beginning of everything. It's pretty much the point where the two axes intersect. So the point where the axes intercept. So if you have a look up here, I'm just going to highlight it in a different color. This green that I've got right there, that point where the two lines intersect each other, that's what we call the origin. Okay, so you read it as 0, 0. So just remember that. Now, how to read or write coordinate point. Okay, when we read or write a coordinate point, it always goes in the order of x and then y. So just remember, this is how you read it. To get the x value, you'd read it as horizontal units from the origin. So you start from pretty much point 0, and then you just count left or right depending on where it is. And then for the y value, it's the vertical unit. So you just go up and down across the y-axis. Okay, that's pretty much how it is. So just remember that. These are the basics of everything. So let's just plot some points. Okay, so I have A, B, C, D, E. You have to be comfortable with fractions as well, because sometimes you may be asked to plot coordinate points where fractions are. So you just got to learn how to deal with it. Okay. So let's just start it off with the first one. Coordinate 2, 2, 3. So I'm going to go to +2 on the x-axis, and then I'm going to go up to +3 on the y-axis, which is right there. So that's A. For B, it's 0, 4. So I'm going to find 0 on the x-axis. It just starts from the beginning, and then I count to 4, just right here, which is B. For part C, this is where it sort of gets hard. There's 5/2 here. You sort of got to break it down into a decimal, okay? Just to help you read it. So we know that 5/2 just equals to 2.5, 2.5. So you just got to find where 2.5 is in the y value, okay? So let's just do this coordinate. So you got -1, and then you're just going to find +2.5. So that will pretty much be right here. And then you sort of get the gist of it, okay? Now, 9b, graphing from TOV. TOV just means table of values, okay? So just something that you need to know. We use two variables. We have X and then we have Y. These are the two variables that we mainly use. This is very important right here. The Y value is what we call the subject, and that's the output. So think of the output as like, this is what we get, okay? And then X is like the value that you substitute in, and that's what you put in something first so you can get something in return. Okay, just think about it like that. Okay, that's what you need to know so far. So this is just an example. We'll walk through it. So obviously you're given your rule already, and then what you're gonna do is you're gonna pick out some x values. I preferably pick around 5. Okay, pick between 3 to 5 x values. This will be enough to like establish a pattern. Okay, and now you just work through it. So let's just like, you know, Since I've already selected my x values, it just makes my life a bit easier. So let's go to the next one. Step 3 is solve for y. What am I going to do? Substitute x values into my equation or my rule, whatever you want to call it, and then calculate for y. So I know my rule is y equals 2x minus 1. Let's just try substituting in x equals to -1. Okay, so y equals to 2 bracket -1 minus 1. And then this should be pretty straightforward from here on out. You have 2 times -1 is -2 minus 1. And -2 minus 1 is just -3, okay? So you can just put -3 in the box right there. You can pretty much do step 3 and 4 together at the same time, but you'll get the gist of it. So now let's just substitute our next x value, which is x equals to 0. So y equals to 2 bracket 0 minus 1. This now becomes 2 times 0, 0, and then 0 minus 1 equals to -1. So you put -1 in there. And now you're just going to do the same thing for the last value. 2 times 1 is +2. And then I just have 2 minus 1. Just like that. So that's it right there. The final step is to write your table value numbers. Okay, I'll just say numbers as coordinate points, okay? So because you read a coordinate as x and then y, you have to put it in that exact order. So you go, so I know my x value is -1, and then my corresponding y value was -3. So that's why I got the coordinate point -1, -3. And then you just do the same thing with the others right there. So you got 0 and then -1. I put in x equals 0 and I got y equals -1. That's a coordinate right there. And then obviously, finally, you got the other one right there. Um, so I put in x equals to +1, and then my corresponding y value was +1 as well. So that's my coordinate point. Now, the final step is to actually just graph it. So what you're going to do is you're going to put these coordinates that you found earlier onto your graph. So I'll just plot -1, -3. So I'm going to go across the x-axis to -1, and then I'm going to find where y equals to -3. There we go, right there. And then next is 0, -1 is right here. And then +1, 1 right there. Make sure your x and y axis are labeled, okay? And then the final thing is to like sort of grab your ruler, you just connect it with a line, okay? Now it's going to be hard for me to do it because I have to line it up perfectly, but you pretty much get the idea, yeah? You just connect it with a line straight afterwards. All right, next thing you need to know is checking if a point lies on the line. So basically, it's just like, hey, you got a line here, and they give you some random coordinate point, and that random coordinate point has to be on this line here. If it was like here, like somewhere not on the line, you can pretty much figure it out. And I'll show you how to do that right now. Okay. So the question says decide if the points 1, 3 and -2, -4 lie on this graph here, y equals 3x. So yeah, that's really important right now. Step 1, look at the x values in your coordinates. So as you can see here, I have x equals 1 and then x equals to -2. What I'm going to do now is substitute these x values into my rule. So I have y equals to 3 bracket 1, and I have y equals to 3 bracket -2. Step 3 says solve for y. Okay, so let's just go. I'm just going to rewrite what I wrote down in step 2. So y equals 3 bracket 1, and then y equals 3 bracket -2. Let's just solve for y. I end up with y equals to +3. for when x equals to 1, and when x equals to -2, y equals to -6. Step 4 here says compare if the y value matches the y value in your coordinates. So let's just double check our coordinates again. So we had coordinate 1, 3. So we had coordinate 1, 3. And then we have coordinate -2, -4. Yeah. So we're just going to have a look, okay? So look at this number that I solved for, and you compare it to the coordinate. Because they match, that means the coordinate 1, 3 is on the line y equals 3x. So that's cool. Now, let's just check our second one right now, our second coordinate point. I've got here y equals -6, but my coordinate was -4. So that means these do not match, which means that the coordinate -2, -4 does not sit on the line, okay? Coordinate -2, -4 is not on the line. Y equals 3x. All right, chapter 9c, finding the rule using a table of values, okay? Now, when I taught you this earlier last term, this is how I sort of displayed it to you, just to sort of like get started. So as you can see here, you got, so these are like numbers, okay? These are numbers here. Like you've, instead of a box, it's like a number. But now that you've gone through the whole chapter, you now know that this rule right here pretty much looks like y equals mx plus c, okay? And this is very important. And you know that the value, the coefficient of x here is pretty much what we call the gradient. And then your constant value is officially called the y-intercept, okay? Now, obviously, when you draw a line, you got to think about it like a staircase, so you should know what it sort of looks like. And to do that, it's how much the y changes when x moves one step across. So that's the logic right there of the staircase, okay? Now, the coefficient of x, aka the gradient now, tells you how much the y value increases or decreases. Okay, it changes. It changes. I'll just make it this color instead. So I'll use blue for increase and then green for decrease. Okay. Yeah. So if the gradient is a positive number, that means the line goes up, and that means the y increases. But if the gradient was negative, that means the line is going downwards and the y values decrease. Uh, so the constant, aka the y-intercept, is the value of y when x equals to 0. Okay, and if you remember, this is based off. Sorry, this is pretty much based off the, like when you find, like finding y-intercept. So this is chapter 9F, if you remember that. Okay. Now, let's actually do what we're wanting to do. Finding the equation from a line using the table values. So typically you'll be given a table, or like maybe you're asked to create one. I'm not too sure. But what you're supposed to do is um, look at the y values, find pattern. So as you can see in my first example, I can see that my y values are increasing by 2 every single time. This pretty much translates to be the gradient. Okay. And then to find the y-intercept, you just got to look right here. It's the value of y when x equals to 0. Okay. And as you can see, it's 3. Well, it's positive 3. So that means your constant is just positive 3 right there. So this is your rule right here. Okay. This is your rule. Now, if you look at the second example, you can see the pattern is minusing 1 every single time. So I know my gradient is going to be negative 1. So it should be technically y equals to negative 1x plus c so far. Now, obviously, we're just going to find x equals 0. And what's the corresponding y value? It's negative 1. So we can just replace the c with negative 1 like that. Now, when you see two sides next to each other, you got to combine it, okay? So in this case, it's a plus and a minus. So it actually becomes negative 1x minus 1. But the thing is, this isn't like the actual correct answer. If you remember correctly, in algebra, you don't put the number 1 in front of the variable, remember? So this now turns into, let me just write it up there. Becomes y equals to negative x minus 1. So that's the official equation right there, okay? Now, what happens if your table of values doesn't give you x equals 0? So uh, x equals 0 is not given, okay? So I'm actually just going to fix this real quick. This sentence doesn't make sense. What happens uh, when when x equals 0 is not given? There we go. So let's just fix that up real quick. Okay. So what you're going to do is you're going to substitute another pair of coordinate points. So if you remember from previously, I said if you just look at the table, these are combinations of coordinates here. So these could be, I'm just going to write the coordinate points on the top. These are written as 2, 5, 3, 7, 4, 9, and 5, 11. Okay. You can pick any one of these coordinates. It doesn't matter. Okay. Now, if you remember, the coordinate point is written as x and y. I think this photo is quite confusing, so I'm just going to get rid of it. Since I already know what my gradient is, I can just write y equals 2x plus c because I know that the gradient is 2, okay? M equals to 2. What you're going to do is substitute one of these. I'm just going to pick a different number. I'm going to pick the number 5 and 11, okay? You can pick any coordinate. It doesn't matter, okay? Because these are written as x and y, so wherever I see x, I'm going to replace it with the number 5. And then wherever y is in my rule, I'm going to replace it with the number 11 instead. Okay? So let's just do that. So 11 equals to 2 bracket 5 plus c. What you're going to do now is solve for c. So it becomes 11 equals to 10 plus c. And then when you do your standard solving shenanigans, you actually end up with c is equal to 1. That means the rule of the line is y equals to 2x plus 1. And you will get this same answer regardless of whatever coordinate you substitute into, okay? Let's just do another one where you're forced to find um, the constant when you're not given it in the table. So we're going to do this one right now. Okay. That one's the more important one. So let's just look for a pattern first. What's my pattern? As you can see, they're pretty much subtracting by 2 every single time. So I know that m equals to -2. So so I'm just say y equals mx plus c. That means y equals to -2x plus c. Now I'm going to pick a coordinate point. I've already selected one out already. So it's 3, -5. I'm going to substitute, okay? Just like that. So wherever I see x, I'm going to replace it with the number 3. Wherever I see y, I'm going to place it with the number -5, okay? So -5 equals to -2 bracket 3 plus c. And then you just got to solve for c, okay? So -5 equals to -6 plus c. What you're going to do is apply the inverse operation of +6 to both sides. So you end up with c equals to +1 again. That means my rule is actually y equals to -2x plus 1. And that's my final answer right there, okay? That's all it is. All right. 9D, solving linear equations, okay? Now, how, how you're typically supposed to do it is you're actually supposed to use the graph. But in my honest opinion, that can be quite tricky to do if you can't like conceptualize it. So my alternative is just solve it normally how you would solve a typical equation. Now, I taught I taught this to everyone last term, but let's just talk over it again, okay? So I'd say avoid it if you don't understand it. Just solve for it normally. So let's just do an example here. Use the graph of y equals 2x plus 1 shown below to solve each of the following equations. Now, if you know how to do it by using the graph, do that. But if you can't do that, it's okay. Just solve it how you would normally. So let's just do number A. So I'm trying to find when the line 2x plus 1 equals to 5. Just solve it. So I'm going to apply the inverse operation of -1. So -1 to both sides. I'm left with 4 equals to 2x. And then I divide both sides by 2, just like that. Okay. And then I'm left with x is equal to 2. So if you have a look at the line reaches the point y is equal to 5 when x equals to 2. And as you can see, it's there on the graph as well. As you can see from the dotted line, the line touches y equals to 5 when x equals to 2, which is what you just solve for. So if you just write x equals to 2 after solving it, that's perfectly fine. And now let's do part B. Find a line when it hits 0, y equals 0. So you can look at the graph or just solve for it. So I'm just going to apply -1 to both sides. So 0 minus 1 is -1. And then obviously the 1 on the right hand side just disappears. And then finally, I'm going to divide both sides by 2. So it becomes x equals to -1/2. So if you have a look at the graph, it pretty much makes sense, yeah? So the point where the blue line cuts this red line that I'm drawing right now, it's at x equals to -1/2, okay? And then finally, when does the line cut y equals -4? So let's just solve it normally. So subtract 1 to both sides. So I'm left with -4 minus 1 is -5, which equals to 2x. And then finally, you divide both sides by 2, which equals to -5/2. Uh, let's- this is pretty much negative 2.5, okay? Negative 2.5. And if you have a look at your graph, it makes sense. So look at where this blue line cuts across the red line that I drew, the solid red line that I drew. It's at x equals to negative 2.5. That's pretty much it, okay? Don't stress too much. Just solve it normally, you'll get the mark. Now, point of intersection. It's when two graphs are intersecting or they cross over each other. You can do one of two things: look at graph or solve for it. Okay. Now, if you solve for it, it doesn't do you any favors now when, like, answering the question, but it is good practice because at the end of the day, you are going to solve regardless of the question. Okay. It's just some good additional practice for you all. So I would recommend solving it, but you know, if that's the case, just use the graph. So use the two graphs y equals 4 minus x and y equals 2x plus 1 to answer these questions. Okay? You can look at the graph. Boom, they cross each other at this point in purple. And if you read it as a corner point, it's 1 and 3. Now, if I'm to solve it, what I'm going to do is I'm going to equate it to each other. So make it equal to each other. And I'm going to solve for x, okay? So I'll just do it for those who want to practice solving. Because there's two variables on both sides, you gotta remember, you gotta make sure it's on one side only. So that's why I am subtracting 2x to both sides. I like my variables on the left hand side. So that's what I'm doing. So it becomes minus 2x there, minus 2x. I'm left with 4 minus 3x equals to 1. The reason why it's negative 3x is because over here, this is technically a negative 1 in front, okay? Negative 1x. So negative 1 minus 2, just like that. Next, I'm going to subtract 4 to both sides. So I'm left with negative 3x equals to negative 3 because 1 minus 4 is negative 3. And now finally, I'm going to divide both sides by negative 3. So I'm left with x equals to 1. And then what you're going to do next is you're going to substitute x equals to 1 into one of the rules given. So you can pick any one, doesn't matter. I just picked the easier one to work with. So y equals 4 minus x. So it becomes 4 minus 1, which equals to 3. And as you can see, that makes sense. It holds up. This is the coordinate point right here, 1, 3. Okay? But obviously, using the graph is just a lot easier. Solving linear inequalities. Okay, there's some lines that you need to know. Um, some special lines right here. Horizontal lines, um, parallel to the x-axis. It has a rule in the form y equals c. This is really important. You need to know that. And now, if you're wondering, I know you say here c is any number, but it pretty much just means the y-intercept, or it could be like the y value or the y value of coordinate. Okay. Oh, okay. So yeah, that's just all it is. And then you got vertical lines. It's parallel to the y-axis. Has the rule x equals to b, and the b value is the x-intercept or the x value in coordinate. Okay. And now let's just do an example. It's just I've got a graph here, just tells me what's the rule. Find the rule, okay? Well, I can look at the y value because it's a horizontal line. I know it's in the form of y equals c, and then I just got to find okay, what's that c value? Just look at the y value, or I can just look at the y-intercept right there, okay? So it's actually just y equals to -3, and then in the next one, it's a vertical line, so I know it's in the form x equals b. I'm just going to look at the x value there. So x equals to 7. So, uh, graphing inequalities on the Cartesian plane. So just remember this is related to graphing, okay? It's not like what you did previously, but it's pretty much the same skills, just a bit extra, okay? So it just describes a section or a region on the plane. The shaded region represents all points that satisfy the inequality, okay? Really important. Now, um, when you draw a dashed line or dotted line, okay, it's based on these two symbols here. And that means that the inequality is not included. I've just made this a bit easier. I've just simplified it down. And then you draw a solid line and the number is included. And that's for these symbols instead. Okay. So just know dotted line is for two arrows. And then you draw a solid line when you got the two arrows, but it's got a line underneath them. Okay. Um, okay. So I've sort of done this already. I don't like, I've written it down already just to make my life a bit easier. So you're given the inequality, okay, you got y, whatever the inequality is, -2. You just got to like break down the inequality, okay? So when you say it out, it's y is greater than or equal to -2. So what you're going to do is you're actually going to draw a solid line at y equals to -2, okay? Just like that. You're going to do that. And then you ask yourself, which values of y is greater than -2? So you've got some examples, -1, 0, 1, 5. And and then like you just ask yourself looking at the graph, okay, which direction is that in? It's obviously above the line that I drew. So I'm just gonna just do this. I'm just gonna shade that region only, okay? And that means like I've shaded in the region where all the y values are greater than or equal to -2 as well. Okay, that's it. This one here, this second inequality is x is less than 5. And then you ask yourself what values of x is less than 5. So you have x equals to 4. um, I'll just say 4. You have 2, you have 0, you have -1, all these kinds of numbers. Okay. So first, let's just start out by drawing a line at x equals to 5. And then just remember, what kind of line do I draw? So because the inequality doesn't have the line underneath it, I am just going to draw a dash line. So let's just draw a dash line. Bam, 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 bam. I'll just label this as x equals to 5. I'll label this as y equals to -2. And now you're just going to shade that region. So you're going to shade the region where you see x is equals to 4, x equals to 2, 0, -1. And that's just towards the left-hand side. Okay, that's just all it is. Now, what if they ask you to solve for it? Okay, so they're gonna, yeah, it's a bit weird. So they give you like an inequality, and then you got to find like a specific region. Okay, So this example doesn't really do it justice, but basically think about it like this. You have your line. It's like which area of that red diagonal line does it sit underneath y is equal to 5? Okay. Now you can use the graph. My solution is to just solve it normally. So you just solve your inequality like normal based off the previous topic that I taught everyone. Okay. So just apply the inverse operation. So 2x is less than or equal to 4. And now you divide both sides by 2. So that means x is less than or equal to 2, just like that. And then you're done. Just do the same thing, okay? Just solve it. Don't worry about the graph. Just make your life 10 times easier. If you solve it, you will be fine. So this will be 2 plus 1 is 3. And then you divide both sides by 3. So x is less than or equal to 1. And if you really want to double check, so I'm just going to draw a line at y is equal to 2. And it's like, okay, where does it cut? Where does the blue line cut that purple line? As you can see, it's right here, and it's at x is equal to 1. Okay. So, but don't worry about that too much. I would say just solve it. I'll do one final example. This is something really important because this is where a lot of people make mistakes. So just be careful and pay attention. But if I were to solve this normally, I'm going to add 2 to both sides. So it becomes negative x is less than 4. Now, the final thing here is you need to divide by -1 because you see that negative sign right there? You got to get rid of it. So you divide both sides by -1. So and it becomes x -4. But what happens, most importantly, is the inequality sign changes. Okay, so just remember that. Remember to change inequality sign. Okay, just like that. I'm gonna stop it here and then I'll just make like a second video talking about this, okay? But this is part 1 of chapter 9 revision, okay? Take care. Good luck.